The molarity of a solution and its volume are inversely proportional. Therefore, adding water makes the solution less concentrated. If you look at the formula, molarity is equal to moles per liter. If we increase the volume, which is in the denominator, that will in effect cause the molarity to decrease. The inverse relationship takes the form of molarity initial time volume initial equals molarity final time volume final. I like to rewrite this equation in something a little bit more usable. I like to say the concentration of the concentrated time the volume of the concentrated is equal to the diluted concentrated term time the volume of the diluted. It doesn't matter if it's molarity, it could be any unit. Okay? Doesn't matter as long as it's the same unit on both sides, it cancel out. So C is any concentration, ppms, molarity, normality, whatever. And the volumes just have to be the same unit to cancel out. Now, the word of caution here is that you only use this for dilution calculations. Do not use this for reactions, because if the reactions are not one-to-one, then you got to account for the mole-to-mole. So only use this for dilution calculations. Here's an example. Describe how you would make 100 milliliters of 1 molarity ammonia from a 14.8 molarity ammonia solution. So this is dilution. I'm taking a more concentrated solution and making something more dilute. So this is a perfect example of using our CV equals CV equation. So now we got to figure out what goes where. We have 100 milliliters of 1 molarity. That is the diluted version. So that's my volume of my diluted and my concentration of my diluted. And I'm taking that from a concentrated solution of 14.8 for my concentration, and then I'm trying to figure out how much of that I'm actually diluting to 100. So we plug in our numbers. Solve for VC. So I get 1 molarity times 100 molarity divided by my 14.8. Set up that my molarities cancel. So long as it's the same units, it'll cancel. Tells me my volume is 6.76 milliliters. However, that doesn't answer the question. It asks for how to describe how you would make one. So I need to go a little bit further and say you must take 6.76 milliliters of your 14.8 molarity of ammonia solution and dilute it to 100. Now, where is that different than saying 6.67 and add 100 milliliters? Well, if I add it, then that's 106.76 milliliters, which means it's more dilute than I expected. Okay, so it's a case of diluting to the mark. So I will take 6.76 and add enough water to get the total solution, your solute and solvent, to 100 milliliters. Homework 35.